Hello and welcome to the code section. We'll start off by going into the top design. Here we can see the hardware that I used in order to implement my Connect 4 game. We have the LCD display, touch capacitor, CapSense, the two physical buttons right above the LCD display. We have an analog digital converter for the potentiometer. We have two timers, one to refresh the display and the other for flashing the pieces on a win. They're both driven by a 24 megahertz clock. The UART is used to communicate with the XB, and the control register here is used for controlling the rows and is assigned to these pins, obviously controlling the green columns and purple columns. Pin layout, there was a lot of them because I did the direct connect way. It was a little challenging with all the pins, but it saved me having to wire the shift registers, which I found to be nice. Nothing special about the pin layout other than they were just all on the same side except for the CapSense. The CapSense needed to be these particular pins because that's how it's laid out on the board and it's described in the datasheet. Potentiometer is fixed because it's a fixed pin, and RX and TX were just chosen for convenience. Looking in main.c, I included the standard library and math.h header files because I wanted to do some absolute value and power taking, and they had those in there. I created a type which I called player T and defined two variables, green and purple. So the enum that I defined for the player T was obviously for green and purple player. We have a list of global variables here. We have the green player's board and the purple player's board, both 2D arrays of 8x8 to encompass the entire LED matrix. We also have a winning row and winning column. These are used later to actually store the winning positions so they can be flashed to the LED matrix. And we have current column, old column, and current position, win, quit, flash. These are all just flags used. Well, most of them flags used. These are actually stored for selecting the current column and seeing if it's changed from the last one, and this one is for the wireless row because we only want that row to be sent when we are actually using the XB. So we have some function prototypes here. We've got the local game where the local game is played, wireless game where the wireless game is played. We have our send packet, which we use to send packets to the XB. We have our get package, which we use to receive packets from the XB. We have our change channel function. The shared functions between the two game modes is display, obviously, because we need to be displaying to the LED matrix in both cases. We have a select move, which is highlighting the player's current position on the home row of the board. And we have a board function, which is actually used to place a move onto each player's board. We have check board function here, which checks each player's board after a move is made for a winning condition. The winner function here takes the winning player and flashes their winning pieces. The quit game function is used to quit a game that is in progress. Moving on, we have the interrupt routines. This one is used for refreshing the display. We have the flash conditions, which just takes a flag and sets it not equal to itself, so either 1 or 0, and is going to write it to the moves, creating the flash effect. Obviously, it'll flash on and off for the duration of the timer set up in the top design of the hardware that we showed before. These two interrupts are used to grab the physical buttons. Inside main, we see that we have first the enable of global interrupts, starting of our hardware, and the one-time setup for the XP to write to volatile memory. We have some local variables, which is the game, which is either going to be local or wireless, and then if one has been selected, we initialize the board, and then we go into our infinite for loop, which will be running for the main menu. It displays a header, gives you two options to select, which are selected using the touch capacitive slider, and an option is actually taken when the bottom touch capacitive button is pushed. This is checking to see if the bottom button has been pushed and not the top one. If it has, checks the game and sets it to 0, which would be a local game, and says one that is selected, because now we have selected either local or wireless. And when a local game has been selected, we come into our local game function, which is going to continuously run and not return back to main until rematch is false. So we start with rematch equal to 1. Once again, we're scanning our touch capacitive ports. We have our quit game function, which checks for button 2 and button 3 being pushed in order to quit a game. More on that later. We print the local display stuff to the LCD. If it's the green player's turn, then the green player has an arrow in front of their name, and if it's purple players, they have an arrow in front of theirs. This is where the select move function is called. It's only called when the touch capacitive button has been touched, and a move is dropped when it is the player's turn and they have pushed their appropriate touch capacitive button. This calls the board move, which will either place the move on the board and return the next player, or will not place the move on the board and return the same player so they can try again. If there's win or quit has been selected, then the rematch flag will be set based off the winner of the player. So we come down into a wireless game. It's the same basic setup as a local game, but it starts off by calling the function to set the XP channel. It too runs in an infinite loop waiting on the rematch flag. In this case, we are displaying on the second line of the LCD the channel, opponent's ID, as well as the player, green, purple, a little smaller because we needed to save some space. Here's where we actually can set the channel based off the button 2, and when button 2 is pressed, we can come into here and use the potentiometer to select our current channel. It's only applied, though, if the channel has changed from the previous value. This saves us load times from people accidentally pressing the button. The player ID can be changed by pushing button 3 and, once again, twisting the potentiometer. We have that I've already covered. Once again, selecting moves is the same as in local play, but this time the wireless row, which is set to -1 here, is going to be the row that's passed to the opponent. I had to do this because I need a special flag to contain the wireless row, because in my local game I was not using rows to play a move. It was calculated on the fly based off the current state of the board. It's set to -1 in this case because when we're selecting a row on the home row, we do not want to be sending packages to the opponent. The home player move is implemented when it is their turn and the column is not out of bounds. When there is their turn and it is no longer the first move, then first move is equal to 1 and no move is equal to 0. When first move is equal to 1, then we know that we have gone first and we can start sending packets here with the send packet function. The no move flag is used here so that when no move has been played by either the green or purple player, there's no arrow indicating whose turn it is. The away player's moves are read from the getPackage function, which takes a player ID, a player, and the no move flag. The opponent column is then extracted from this packet received by the opponent player, and then is used to determine whether or not the opponent has played a move and is if their turn. If it is their turn and they've played a move, then it is placed onto the board and the new player is returned. Once again, win or quit signals will trigger the restart of the game and go into the winner function. Here we have the set channel function, and it takes an integer for the channel that you want to set based off the potentiometer value. This is used to display the progress of the setting channel. We send the ++++ command to the XB and to let it know that we would like to start sending it a list of commands. This is where we select which channel we're actually going to do in character form based off the integer that was passed. Once it's done, it will go ahead and send one last command to the XB saying that we would like you to return what channel you're currently using, and that is what is printed to the screen to verify that we are indeed on the correct channel. Creating a packet takes a column. Sending a packet takes a column because, like I said before, mine is based off of just sending a column and calculating the row on the wireless or on the current state of the board. It sends packets, obviously in uint8, and it's a 13 wide array. So when the wireless load is not equal to -1, which means that it's not been selecting a move and it actually is a legitimate move to play, then it builds the packet into the array, puts in the correct row and column, and then calculates the checksum based off this row and column packet, and sends it to the UART, which then in turn sends it to the XB. When we are receiving a packet, we need to know the player ID that we want to receive from, whether or not it's the player's turn, and if no move has been made. This is done by taking the received packet, and we receive the data from the UART, and we check that first piece of the packet from the UART to make sure that it is indeed the start bit. So if it's the start bit and it is the opponent's turn, or no move has been made, which means that it could be either person's turn, then we go ahead and we grab the entire packet and place it into our receive packet array. When we have finished absorbing the entire packet, we come down here and display to the first line of the LCD display the row that we have received, the column we have received, and the player ID that we received it from. We now check to see if we are going to use this packet by checking the player ID, the received packet is in the correct range of the board, and that it is a valid move on the current game that we are using. If all of these conditions are held, then we grab the column from this packet and return it. Otherwise, we return -1. This is the function that displays to the LED matrix. It cycles through all the columns in a particular row, and the row is incremented at the bottom. When it's cycling through the columns, it is checking the green moves on their two-dimensional array for the given row, and the purple moves in the two-dimensional array for the current row. It then accumulates all LEDs that should be on in this row by doing a power of 2 and adding it to this variable. I did power of 2 to whatever position in the column it was in, so that it would give me a 256-bit value to write to my control register. When the row has incremented past 7, we reset it to 0, giving us our refresh rate. Select move simply uses the touch capacitor slider, and if it is the green player's turn, then green is shown on the home row and is moved side to side from 0 to 7, and the same for purple. Once a move is if a move is changed, then and only then is it actually applied to the current column that we're showing. Otherwise, the current column stays the same, and when we are done, we return the current column. This is the board function to actually place moves onto the board. It takes the column and the player that it was going to place it to and returns the new player. The first thing we do is confirm that the column is indeed valid, and if it is, we make sure that we reset the column to 0 on the home row, because we know that that was just for selecting purposes. We find the next free row in the current column for both players' boards by cycling through till we find a 0. Once we have a 0, we know we have the current row. We make sure that the row is valid, and if it's the green player, then we go ahead and we add the move to the board by placing a 1 there, and we set the wireless low equal to the row for the wireless game case. This is not used for local play. We then check for the win by calling the checkboard function. This will return a win condition, and if it is not a win, then we increment the player to the next player. Otherwise, it stays the same because we know that that player is the winner. It executes the same list of commands for the purple player as well. When an invalid move is played, then we know that the column was out of range, and we can tell the player that that is not a valid move. This is only a case when the player tries to play a move without first touching the slider. This condition was eliminated just now because it was realized that it was not needed. Once we are done, we return the next player. To check for a winning condition, the board of the current player and the row and column are sent to the function. What this function does is it goes in the 7 possible directions and checks for a win. So those directions being up at a diagonal right, down at a diagonal left, up at a diagonal left, and down to a diagonal right. Those account for the 2 diagonal moves. And then we have the 2 horizontal directions that it could go in, as well as the 1 vertical direction down that it has to check. It checks each of these conditions by using a different offset and cycling through the board until it reaches a 0, or the total number of pieces in the search has reached 3, because we know that we already have the starting piece, so we need 3 more for Connect 4. Winner's dance is the winner function. It takes the winning player, and in the case of it not being a quit game that was quit before a winner was crowned, then we come in here and we display the winner message that whichever player who wins, which is identified by the player passed, and the instructions to continue. Once the continue instructions have been met, the player is asked if they would like to have a rematch. The rematch has to be chosen by the losing player, but the slider being controlled by either player. When I say B can only be selected by the losing player, I mean the losing player's touch capacitive button is the one that increments the game yes or no. This is the condition to check for a game quit. It is the last function. It is taken any time that button 2 and 3, the physical buttons, are depressed. And the game is either quit or not quit based on the slider position. There's no button other than the 2 physical buttons being pressed down and the slider to select yes or no that need to be done in order to quit a game. Thank you for bearing with me through this long section of code. I do hope that it wasn't too bad, and it does pain me that I did this all in one file, but that's what happens when you have limited time.